Hello again. So this is my third and final video that I'm making in these same clothes. So sorry about that. I know I told you I wasn't going to talk about the setup of the ISN again, but I am because I kind of made a mistake. Whenever we're putting our page numbers, and I made these foldables and printed them off, the page numbers are not correct. So just so you know, if you've already written in your page numbers and you haven't caught on to the fact that they're not on pages 5 and 6, then ignore the foldable and fix these. Other than that, just make sure that you fill in your lesson title, you fill in your word worth knowing, and then whenever you get started, also fill in your lesson title, which I haven't done on mine yet. Okay? So let's go ahead, and this lesson is kind of involved. The knowledge behind exactly what a radian is. So we're going to go ahead and just jump right into the thick of it. So the first thing we're going to do is talk about the relationship between degrees and radians. In the vocabulary video, I already told you that radians are just another way of measuring degrees. Degrees are kind of arbitrary. The Mayans just said, hey, let's say that a circle has 360 degrees, and that was it. Okay? Well, that's how they came about, if you ever wondered. So with radians, it's a little bit different. Mathematicians actually created radians by dividing the length of an intercepted arc by the length of the radius. So I went ahead and wrote this down ahead of time because it's kind of long, but go ahead and write that down and pause it if you need to, and then start the video again. So to kind of illustrate what I'm talking about when I say the intercepted arc and the radius and all that, I'm just going to quickly show you a little drawing from last year. I didn't do the same exact lesson, but you'll kind of get the point, and you don't need to write this down anywhere. Okay, so don't draw this in your circle. But you can see here, I wrote a shorthand for that. This is radian measure, theta, okay, because remember that represents an angle, equals s, which is the variable for an arc length, which you may or may not know, divided by r, which you guys know is for radius. So if you look at this picture, the amount of radians in this angle is equal to however long s is. That's an intercepted arc. See how the angle hits it and cuts it off from the rest of the circle? And then obviously the radius length is from the center of the circle to the outside. So in this example, I said, well, S is 5 units long and the radius is 2 units long. And then we found theta, which I've already written in here. So we did the math. We just plugged in S, which was 5, R, which was 2, and we got 5 halves radians, or 2.5. That's all it is. So radians depend on how long your arc length is and how long your radius is. Okay, so jump forward. Now, let's draw inside of our circle. What we're going to do is put a center, because there isn't one. And notice this isn't a coordinate grid. This is a circle. We will be getting to a coordinate grid here in a little bit. But here's the center, and we're going to draw a radius straight out. Okay, and let's say we have an angle that goes all the way around. We're going to call it theta. We know how many degrees the circle has in it, 360. Remember, we're talking about radians, so we don't actually know, so we're going to label it with theta. And then to find radian measure, theta, we have to do S over R. Well, if our angle's this big, then our intercepted arc is actually the whole outside of the circle. That's a very poor job of tracing. Sorry. So the reason why I did this with all these variables is because we can actually figure something out here. We can figure out that, wait a second, the outside of a circle That's something we know an equation for. The whole outside of a circle. Well, that's circumference. And there's an equation for that. It's 2 pi r, if you don't remember. So here, we don't know how big this whole circle actually is. We don't know the intercepted arc length. However, we do know that if we had r, we could calculate it, 2 pi r. So let's go over here and let's say, all right, well, how many radians are right here? Well, let's plug in 2 pi r instead of s. And let's put it over r. Wow, from Algebra 2, you know that these r's cancel. And so theta equals 2 pi. So pi is a number. So that's like approximately, I don't know, 6.28 radians. Wow, we actually got a real number when we didn't have anything over here. That's amazing. So what does that mean? Okay, well, I'll tell you what it means. It means that if this is 360 degrees, if theta is 360 degrees, but theta is also 2 pi, then we know that 360 degrees and 2 pi are equal. So let me say that again. Going around the circle we know is 360 degrees. We also just figured out using math that it's 2 pi radians. So that means 360 degrees is equal to 2 pi. And that's going to teach us the rest of what we're going to be doing with our lesson. That means that we can figure out conversions. Okay, we can convert all the things we know in degrees into radians. So we could divide by 2 on both sides, and we would know that 180 degrees equals pi radians. And remember, pi just stands for 3.14. Okay, so that's the challenging part, is figuring out how mathematicians came up with this. But now converting, well, that just comes down to math and being organized. So let's look at converting degrees to radians first. So degrees to radians. In order to do this, you just have to multiply by pi radians over 180 degrees. Remember, pi radians and 180 degrees are equal. They're the same thing. So basically we're just multiplying by 1. If these two things are equal, when you have something on top equal to something on bottom, they cancel and equal 1. Remember all that? So when we multiply a degree by pi over 180, we're really multiplying by 1. So it's okay. It's legal in the math world. So let's do an example. Say we want to convert 30 degrees to radians. Well, just do what it says. We're going to multiply 30 degrees by pi, and I'm just going to put rad for short. That's the short for radians, over 180 degrees. If you remember from science class or maybe in math class, when you have units on top and bottom, they cancel out. That's why this is converting. And then also we can go ahead and do this like in our calculators, but it's a lot easier to just say, oh, 30 goes into 180 6 times. And then multiply across the top and across the bottom. So now we have pi over 6, and our units are radians. So 30 degrees equals pi over 6 radians. No, it's a little trippy, but that's it. That's all you do. Okay, so now let's go the opposite direction. Say we have radians and we want to know what they are in degrees. Well, you just flip your conversion factor over. You multiply by 180 degrees over pi radians. Remember, we can multiply by this, it's legal, because these two things are equal, And when you multiply by something over something equivalent, it's like multiplying by 1. That's how conversions work. So let's convert this time pi over 3 to degrees. So we've got pi over 3 rad, and it says to multiply by 180 degrees over pi radians. Remember, units cancel when they're on top and bottom. And then we just do the math. So we see we have a pi on top and bottom. Pi that is the same on top and on bottom. It's a number, so we can just cancel those. And then 3 goes into 180. How many times? 60. And so our answer is 60 degrees. So pi over 3 radians equals 60 degrees. And that's all. Okay, so the real thing here that we're going to be stressing in class tomorrow isn't converting, because you guys can learn to convert. And that's fine, that's fantastic. But what's more important is for you to have these so ingrained that when you see pi over 6, it comes just as natural to you as 30 degrees does. You know that they're the same thing in your mind. It's like learning a foreign language. That's what we're going to be doing. So what I'm going to leave you guys with is a couple for you to convert on your own in your ISN. I'm not going to practice them with you because I've already done 2 examples. And then come in tomorrow with these done. And we'll go over them, we'll talk about them, but I do expect you to have them done. If you don't, you won't get participation points for that part of your ISN. So go ahead and glue this in, do whatever you do. And then underneath it, as usual, is where I'm going to put your examples that I want you to do. All right, so we're only going to be doing 4. The first 2 are going to be degrees to radians. All right, so this first one, I want you to convert 45 degrees. And the second one, I want you to convert negative 225 degrees. Now, whenever you come down here and do radians, you're going to go to degrees. On this first one, I want you to do pi over 2, a really popular radian measure that you'll get really used to really fast. And then the next one I want you to do is a real odd one you won't see very often, 11 pi over 6. So try your hand at those, try to convert them, and tomorrow we're going to be working on converting and then memorizing. All right, so good luck with those 4. Make sure you try to do them and you come in with questions. See ya.